Now let's understand the access control list that is implemented in Linux distribution. So to understand the access control list, let's just give a simple example. I'm going to execute the command ls-l. We have seen this table structure before and we have to discuss this particular first few entries of this table structure. Let me give you a simple summary here. These initial few characters like R, W, X, D, these are the permissions assigned to different groups, users, and the other open users, others. Now, after that, we have this username. This is the owner of that particular file or a folder. For example, if we talk about this file demo.txt, the owner of the file is the Kali user. And if I create a simple file sudo touch root.txt, let's just name it as superuser file.txt and hit enter. Now if I'm executing command ls-l, you can see the owner of the file is root user here because I've executed the command with the sudo as a prefix. Now sudo is used, now again sudo is a group here, and this particular group gives you the authority to execute the command on the basis of the root user. And we know that the root is the top level user in the Linux distributions. Root is the highest, or let's say the administrator user in Linux distributions. Now to understand these RWX, like what permissions are assigned to the user, to the groups, and to others, we can simply use a command get facl and we can specify the file name. For example, let's just go with demo.txt, and if I hit enter, you can see the file name is demo.txt and the owner of the file is Kali, which we have seen just right here, and the next entry is the user Kali, which is the group name here. So first one is the username here, second one is the group name, and then this is the size of the file, and this is the last modified date for that particular file. To get these extra details about the modification and their permissions, you can go with the stat command as well with demo.txt and hit enter. You can see these are the different permissions like rw minus, rw minus, and r minus minus. You can see the same permissions here, rw minus, rw minus, and r minus minus for the same demo.txt file. And here you can see we got this access time, modify time, change time, and its birth time as well, including the file size, their inodes, their blocks, and the user and the groups as well. Now, other than this, we can see this is the modified time, this is the size, this is the groups, this is the owner of the file, and these are the different permissions here. Other than this, we can see there is a numeric value as well, like 0664. You can assign the permissions to a specific user according to this Linux distribution. You can assign permission to the user, to different groups, and to others as well. For all the users who are not available in any group, you can assign permissions to them individually as well. And if you want to make a file publicly available to each and every user, you can simply assign permissions to others, which is wildcard for all the users available in any group. Now, if you want to assign the permission, you can use the chmod command. This stands for the change mode. If you want, you can go with the documentation. Just go with the man command for chmod, where you can read about this command more and you can read about their different arguments available as well. After reading this documentation, let's just take a simple check how you can implement the different permissions for different users, groups, and the others. To change the permission, we have two options again. The first one is you can go with simple command chmod and you can specify the plus symbol to add the permission. And if you want, you can use the minus symbol if you want to take the permission back for a specific user, group, or others. Now, this plus and minus symbol will always implement the same permission for all three of them. Like if you want to add the right permission for user, group and other, for all three of them at the same time. You can use this plus or minus symbol. Let's say I want to give the execution permission. Here we have three options like R, W and X. Here R stands for the read, W stands for the write and X stands for the execution. Let me create a simple file so we can execute it later. So I'm just going with simple command nano and just go with execute.sh. I'm writing a simple command echo and my name here as Siddharth Sangwan. Done. Let's save the file. Yes, and done. Now if I go with ls minus l, we can see we have the file. But if we execute this command, if we want to execute this, we can go with dot slash and the file name execute dot sh, and we can see we don't have the permission to execute even if we are the owner of the file, but we don't have the permission available. To give the permission, I am going with chmod plus x for the execution permission. If you want to add the write permission, you can go with w. If you want to add the read permission, you can go with plus r symbol here. But in our case, we just want to add the execution permission and then the file name as execute.sh. Done. We got success, we got no error. If we don't get any error of the command, it means the command is successful. We will not get the success output all the time for all the commands. Now if I execute the same command ls minus l here and hit enter, you can see there is a different color for the file name this time, and we can see the X symbol added to all these three users here. Now if I again go with get facl, but instead of demo.txt, let's go with execute.sh file. Here we can see we can execute the files as well. We have all the three permissions here, right? And we have seen previously that the initial letter of the row defines the type of the file. If it's a file, you will get a minus symbol. If it's a folder, you will get a D, and if it's a shortcut or a link, you will get the L. So the first character of the row defines the type of the entry you are seeing here. Now to execute the command, let's just go with dot slash execute.sh and we get our result. The command inside this file is pretty simple, echo my name, so it will simply print my name on the terminal. If you want, you can write a long script and then you can give the execution permission and then test your scripts as well. But you can see we can execute our commands here. But the downside of this chmod plus x command is that you are assigning permission to all the different users, groups and others at the same time. For let's say if I want to assign a permission only to the owner of the specific file, right? For that case, you have to use the numeric representation for this permission. For that, if you are assigning a read permission, you have to represent it with the number 4. So 4 stands for the read permission, 2 stands for the write permission, and 1 stands for the execution permission. Simple. And if I go with the stat command again with execute.sh, you can see the current permission set is 775. So if you want to assign read, write and execute, you just simply add all these three numbers, 4 plus 2 6 plus 1 7. So we get the number 7 for the users. The second number 7 here is for the groups, for these three R, W and X. And the last number here is for the others. Now you will recognize that we are not discussing the first number available here for the permission. These are not direct permissions, these are the sticky bits. So if you want to specifically assign a permission to a specific user, in that case you assign those sticky bits, which we will cover up in our upcoming session when we perform some labs on the Windows or the Linux machines. Now So we can see that we can assign the permissions on the basis of these characters, and we can also assign permissions for these numbers as well. Let's say I want to take the permission back for execution, but specifically to the others. I want to keep the permission for users and the groups, but I don't want others to execute this file. For that, I can go with chmod. I'll go with 774. It means they can read the file, and if I don't want to read them, you can go with this number 0. I can go with 770 and then the file name execute.sh and enter. Now if you execute the same command stat, you can see we got 770 and we got rwx minus minus. You can check the same with get fascl command as well for the same execute.sh, and we can see the other users don't have any permissions at all. Now the question arises, how you will identify what permissions are assigned to different groups and where these permissions are being stored, right? So all the permissions in Linux distribution, they are usually kept inside this slash etc slash passwd file. This word passwd, this actual passwd file is used to store the password. But nowadays, after the late 90s, or let's say mid 90s, the passwd file is no longer used to store the passwords. Let me just write it down. So when the Linux was initially launched, like let's say in 1970s, this file was used for passwords as well. So this file has multiple entries. Let me just show you the entries first so you can better relate. So I'm just going with the head command, head slash etc and passwd, and we can see few entries here. Now if you will see, we got the username here, like root is a user, we know that. The second entry here between these two colons is X here. Nowadays, for all the Linux distributions, after 1995, you can say, or 1992, if you go with the actual date of the official use of this etc passwd file and the passwd shadow files as well. You can see after 1992, after all the release of Linux distribution after 1992, the passwords are no longer kept inside this passwd file, and now they are stored inside this etc and the shadow file, right? But initially, when the Linux was introduced back in 1970s, these passwords are stored inside this etc and passwd file. But nowadays, because there are some security policies, because of this, to enhance the security of their Linux distribution and the Linux operating system, they removed the passwords from this passwd file and start storing them inside this shadow file. And the main reason was because other user can also access this passwd file to check the permissions, right? Because we can see there are the different entries, like user groups are also mentioned here, like the user groups and their names and their entries as well. Like this 0 represents the user id and this is the group id for the specific user. For example, if I enter cat and I'll go with cat etc and go with passwd file, I'm just filtering this one for the user Kali. Here we can see the user ID for this Kali is 1000 and the group ID for this Kali user is again 1000. If you want to verify, you can verify this with this groups command. Just go with cat etc, or you can verify it from this group file as well. You can verify it and you can filter it as well. Like you can see, Kali has access to all these different groups. If you want, you can verify this with id command, or you can verify it with the group command as well. You can go with the groups and the username and you can see this user Kali has access to this ADM, CD-ROM, floppy, pseudo audio, and all these Wireshark and Bluetooth groups as well. And you can see all these groups have entries related to the user Kali, right? And you know that in the Linux distribution, for any group or for any user, hire their identifier, for including their user identifier as well as their group identifier. If the number is higher, it means their privileges are low, and all the privileges, all the permissions are assigned to each and every file that are available in the Linux distribution. We know, let's say if I want to restrict a user from executing the ls command, simple case, I don't want any user to execute the ls command. Simple, what I can simply do is I'll go to cd/bin folder, and inside the bin I'll ls minus l and simply grab it for ls, and here you can see this is our entry. Now if you check, like go with get FACL and ls, here you can see all these users, others and groups have execution permissions. Simple. But let's say I don't want them to execute this ls command. What I can do is I'll simply modify the permissions of this file with chmod command, just to restrict the user from executing this command, right? And we can add the user inside the group, and we can also modify the permission for these groups as well. In the same manner, you implement the policies and the permissions for the user, for the software, for the files, for the commands in Linux distributions. Now, other than this, if you just go to etc and check here, there are multiple files. We have seen that etc folder is used to keep all the permissions for all the configuration for all the different softwares and different executables available in the Linux distribution, and including the configuration of the Linux distribution itself. Now if I go with the cat command and check etc and passwd file and hit enter, you can see this passwd file has multiple entries available. So if we simply structure this one, the first entry is the username here. The second entry is the password, which nowadays is not available in the passwd file. Because of this, we only get the X here. Now, other than this, we get the user ID here. After that, we got the group ID here, which is again, it could be a numeric value, and again the same user ID will also be a numeric value here. After that, we got the home directory here. After home directory, we'll get the terminal here. Now if we log in with the user Kali, we are working on this particular ZSH terminal here. There are different terminals available in each Linux distribution depending on the developers which Linux distribution they configure for which different terminal. If you want, you can go with this user bin sh as well, you can go with bin bash as well. It depends what Linux terminal you want to use. So each of them has their own pros and cons depending on the developer which they configure for your operating system. Now after this one, if we check the actual passwords of the user, let's say, and we have seen that we have already discussed that the passwords are no longer available in passwd file after 1992, and now the passwords are kept inside this etc and shadow file, but we don't have the permission. If we check the permission, we can go with get facl and the shadow file. We are already available in this etc directory, so we don't have to enter /etc again. Hit enter. You can see the others, and the others don't have the permissions to read the file, to execute the file, or or to make modification inside the file. And if we go with ls minus l shadow, you can see root is the owner of this file and shadow is the group which can access, which can read the shadow file. And if you check with the groups command for the Kali user, this Kali user is not present inside this shadow group or does not belong to the root user here. Simple. Because of which we are not able to read the file directly, which make an extra layer of security to store the passwords. Now, all the passwords for all the operating systems, for all the application, they are not stored in the plain text. All the passwords are always stored in a hash format. So again, you can use different hashing algorithms as well, but in general case, if we go with the tail command just to print the last few entries of this shadow file, or we can go with the grep Kali, we need the permission. So let's just go to sudo, enter the password, and you can see this is the different structure. These are the different entries available for this user Kali. We have a single entry, but again this single entry has multiple arguments, multiple attributes here, you can see. So if we understand the structure here, the first entry is the username. Now after this we got the password here. Now again, password itself has multiple entries. So the first one, the dollar symbol represents that we have an argument here inside the password itself, and the dollar, the after character, the character just after this dollar symbol represents the algorithm which is used to create the hash of that particular password. So in this case we are seeing that the character is y. So y here is used for yes script algorithm to create the hash of the value. After this we can see there is again a dollar. So this second dollar symbol represents the salt value which is used while creating the hash. After this salt we can see we have another dollar symbol here. So after this dollar we have our actual hash available. So the password itself, this entry itself has three different parameters, three different arguments. First one is the algorithm, then the salt value, and then the hash value itself. Now after this one we have few numeric values which represents how many days you have passed since 1970. Since 1st of January 1970, how many number of days have been passed since you changed your password. If I have changed my password on 3rd of January 1970, then the value would be 3 or 2 here. That it's been only 2 days since I have changed my password. Now, these 19982 days represents that it's been 19982. It means 19,982 days since 1971. After these many days from 1970, I have changed my password. Simple. The entry after this 19982 is 0. This represents like after how many days. Let's say if I change my password on 16th of September today, after how many days I can change my password again. If the entry is 0, it means I can change it immediately. If the entry is, let's say, 5, it means I can only change my password after 5 days on 21st of September. So this entry represents the minimum number of days you have to spend with your current password. After this we have again a numeric value which is 99999. This represents the maximum number of days after which your password will be expired. Let's say if the entry here is 100, it means after 100 days your password will be expired and you have to change it before the password expiry. Now after this one we have again numeric entry, which is 7. This entry represents that we have to change the password before these 9999 days, and we will get an alert before 7 days of their completion, right? So this represents the alert. When we will get the alert before 7 days of expiry, we will get an alert and the password will be expired after these many days, and we can change it after 0 days or immediately or after 10-20 days. And we have changed our password after 19982 days if we calculate it from the beginning of 1st of January 1970. This is a simple structure which is used in our shadow file. Now, the simple question is, if I go with tail command, a general tail command, sudo tail and shadow, not all the files have these passwords. Not all these files has these passwords. Few of them have this exclamation symbol and exclamation with an asterisk symbol. So if you are getting an exclamation symbol, it means your account is inactive. If you are getting a asterisk symbol, it means your account is disabled, right? Your account is inactive and your account is disabled. So these kind of values can also be there for these users. Again, one more thing, if you do the same command sudo, and I'll go with, without sudo you can read the passwd file. So let's go with tail and read the passwd file. You can see the terminal here for the Kali user is user bin zsh, right? And whenever we log in, whenever we start our operating system, and we have to log in our user, right? We have to enter the username and password to access the user profile and access to this particular user interface. Now whenever we enter the username and password, we get access to the system. If you want to restrict a user to log in inside the system, all you have to do is just change their terminal to no login. The user will not be able to log in inside the system if you want to restrict the user from login. Simple, right? So this way, if you get no login here or bin false here, the user will not be able to log in, or they don't have direct access to the system itself. They have to log in through the user itself. For example, if I go with cat passwd and I grab for sshd, we simply use SSH and the username with the IP address to access the SSH service with the user account. Now authentication is done with this particular user ID and the password for the user, not directly with the SSH service. That's why we got this user bin no login. It means the service itself does not support the direct login to the operating system. You have to log in with the other users. Like Kali, you can access the service with other users, you don't have the direct access to the login. Simple as that. So this is how a general access control list or the permissions are implemented in the Linux distribution.